if you're working on this, trying to decide what you're doing, one of the functions y equals x cubed looks something like this, more or less, except that's not drawn very well, but you get the idea? It's good enough.
I think the other one was better.
The other one was better, you're right. Undo twice. Third time it'll be, I'm glad I'm recording this.
No, me too. There you go.
Okay, and the other one looks something like what? What does it look like? It ends at -2 and comes back this way. Except you probably want to draw it so that it's clear that it comes back before it does that. If you want this area in between them here, if you're doing it to the x-axis, you need to split it into two things, to two regions, because if you just do this curve minus this curve, since this one seems to be higher up, it's okay up to this point right here, right? That it's okay for everything in there because it's the difference between those two curves. But to this side of that dotted line, it's not in between those two curves. It's in between this curve and itself, right? If you're doing it with respect to the x-axis, you need to split it into those two regions and do each one separately. So if you were going to do this, I don't know how many undos I need. There we go. If you're going to call this, I don't know, area 1, this is area 2 if you're doing it this way. Area 1 is integral from, this is -2 up to, what is this value here? Anybody figure it out? -1? Okay, so my drawing's not great, but that's negative, this is -1 here. So -2 to -1. And it has to be the top part minus the bottom part. Or you could make it simpler since you can see the symmetry of it. So you could do it as top part minus bottom part, right? You could say it's the top part is if you rearrange this so it was a function of y as a function of x, it would have to be x plus 2 y plus or minus square root, right? If you isolate the y. The top part is the plus, the bottom part is the minus. So if you really wanted to do it that way, you'd have to say it's positive square root x plus 2 from 2 to 1. Well, no, this would be kind of crazy to do if you didn't recognize the symmetry. Negative square root of x plus 2. I think it would be a lot better to just realize it's twice the area, right? It's that and that are equal, even though it doesn't look like that on my picture. It's a lot easier to just say it's twice this. Okay, 2 times that with respect to x plus the integral from -1 up to, what is this intersection point here? Is it 1.21? Anybody agree with that? You should probably store the number in your calculator to have it more decimal places than 2 if you're using it. That's the y-axis. So this is 1.79 if you're doing it. This is if you're doing it with respect to if you're taking slices this way, right? If you're slicing it vertically to the x-axis, right? If you're doing rectangles that are like this, where this is dx and the height of the functions, the difference there, you end up with, then we need the difference between, what do we need the difference between here? Square root x plus 2 minus the curve underneath, which is x cubed dx. This will work. Okay, this will work. It just requires you to turn this into something involving square roots there. You can use a calculator to evaluate that. You can do it analytically. Don't think you have to do it analytically. You can use the calculator once you set up the integrals like that. Let's call this method 1. I don't know, vertical slices or rectangles. dx. Good idea. Method 2 here is doing it the other direction. Doing it the other direction for this one actually makes it easier. It's not always going to make it easier. I don't want to give you that idea, but if you know the two y values, one of which you said was roughly 1.79, so I'm just going to, should we just call this C and this one D here, or whatever it is, I don't know. You can do the area all at once then, because you can do, it's the difference between the same two functions the whole way here. Okay, it's if you look at it this way, it's the difference between the same two things the entire way. You don't have to split it into two pieces. You just go from that point, that's C, from C up to D, which is the higher up function if you're looking that way as though it's sideways, right? This is the more positive direction. So the x cubed one this is the higher up function. Has the greater value, right? So you have to do that one as the first one here, x cubed. Sorry, not x cubed. We have to change that one actually to, we have to change this one around. How do you change that one around? This is x equals cube root of y, which you might want to write, if you're doing it analytically, you want to write that as y to the 1/3, but cube root of y minus the other function, which is easier this way because it's already written like that, y squared minus 2. You need the minus 2 in brackets if you're doing it that way. And there's a dy now. If you're doing it dy, everything in there needs to be in terms of y. If you have x's there, you need to change it around first. Either one of those, if you do them, again, if you're doing it on the calculator, I'm not too worried about for this unit all the analytical steps. You can evaluate it either way, whichever way you want. But I think it comes out to 4.21 or something like that, is according to the answer key. Is that right? 4.21 square units, whatever they happen to be. You can use your calculator to evaluate integrals. You can use your calculator to solve the system to find those points. You don't have to show steps that you would in grade 11 for finding these intersection points here, those 2 points. You can use your calculator for that if you need to, right?
Does it not matter about the negative part?
It doesn't matter about the negative part because we looked at this last time, but when the values are negative, we're subtracting them here, right? Like for a rectangle, I'll just redraw it here so I don't mess up that picture. But if you have a curve that's like this and another one that's like this, for the parts where both of them are positive, like you're adding up rectangles like that, sort of. If both of them are positive, it's this function minus this function. It works, they're both positive, right? For a rectangle in the middle here where positive, negative, when you do this positive value minus this negative value, when you subtract the negative, it adds it on, which is what you want, right? Because you want that area plus that area. Oops. And then when you have a rectangle that's on the bottom here, the first thing here actually is a negative value, but you don't want it, right? Because it's not there. You don't have that area. You just want this area, right? I think I'm crossing things out. I should have drawn it better. But what you want is that little area. You want this to not be included, but this to be included. So when you subtract a negative, take away another negative, you end up with that little leftover part. It works out either way, whether they're both positive, one's negative. Okay? It's only going to, if this ever crossed over, like if we continued on to down here, then this would take away from it because they've switched sides now, and that's when that area is going to become negative. Anyways, set up the integral either way, but sometimes it's going to be easier one way than the other. If you're doing vertical slices there, you need to have two different integrals because of this, because it's between two different functions in different spots. But the other way, it's always between the same two functions. All right? Now that you've mastered that, I mean, there are some extra questions here. I don't know if you feel like you need to do one or two more before we go to 3D. Now in 3D... What? No, seriously.
Oh my god, I got it right.
Calculus 12, now in 3D.
We actually do 3D. Where are the glasses?
We need glasses, that's right. We are going to go to 3D here, right?
Let's go to Colossus.
HD, I don't know what they're going to do, 3D, and then a little TV channel here, right?
30 minutes. spice in H3.
Oh,
What?
Like they did.
Oh, you were excited? You thought I actually meant?
I don't know
You're
what
saying-
I was expecting. I was expecting
Integrals just going right by your face everywhere.
like
10 minutes. 10
and then,
minutes.
like,
10 minutes.
10 minutes, so this.
Okay, can you keep
I was
scrolling?
expecting time in another dimension.
Yeah.
You're expecting.
Just boom. Looks like the
Can you
stuff to blow your mind.